So hello everyone, in this video we are covering the vectors. Vectors are geometric quantities, which have magnitude as well as direction. So we use them very frequently in our algorithms. So let's see an example. So right now what you're seeing, it's a point which the coordinates are controlled by these sliders. So let's go to transform Euclidean and move. So what it does, it takes two inputs. The first one is a geometry. You can put any geometry over here, and the second is the slider. Actually, the translation vector. So if you want to move geometry to a particular point, so you can use this component. So let's connect our point. Now, if I zoom out, you can see. Let me pan it first. Now you can see that the point is visible in Rhino. So if you can see, it has says translation vector has moved for 0010. So the point has risen for 10 units. So let's go to the vector and unit x. So what happens when we connect it? You can see the point, it has moved for just 1 units. So unit x means a vector which moves for only 1 unit, and the direction is in x direction, and the magnitude is 1. So let's connect a line between the unit x, between both of these points. So to do that, double click search line, not this one, we don't need this one, line, yes, 2-point line. So this 2-point line takes 2 points to draw a line. So our first point is the moved point, which is here, and the first one is the old one. So you can see there's a line. So here you can see I've drawn a vector which have a magnitude of 1, and it is in the direction of x. So let's draw vectors in all directions. To copy these, let's drag and press alt. It will copy. So now other two vectors we are moving in y and z direction. So let's bring unit y and unit z here. From vectors unit y, vectors unit z, let's connect them. Let me clean it. So here you can see that we've got the unit vectors in x, y, z in all directions. So what would happen, it's if we change these sliders. So let's do it. Let me zoom out first. So when I change, let's change x first. You can see the whole thing is moving. So what we thought earlier, that it might change the the magnitude of the vector along x or y or z, but it is moving the whole system. It is happening because the vectors move according to their own origin. So if you look at, we are forming vectors here, and that for this vector the origin is this point. So if we want to change the magnitude of the vector, we have to do something here. But if we are changing values here, we are actually changing just the origin for the vector. So if you want to change the the magnitude of any vector. To do that, bring slider. So I am copying this slider. Press first drag, then press Alt. So now I'm connecting this with X. Now you can see the in Rhino that the length is of X is changing. So if you want to change the the length of the vector, you can change it uh, using the slider. So let's copy it and paste it in Y and Z directions. So now you can see I can easily change the magnitude, even the origin, using these functions. So let's see some functions which we get here. So one thing that which I have told you that the vectors have magnitudes as well as direction. So how? So let's change the direction. Go to reverse. So to do that, let's change the direction of X component. So connect it here and this one. Now you can see the direction has changed. So with the help of reverse, you can change the direction. And there's a component named vector length. You can even measure the length of any vector to see the length. Let's bring in panel. Now you can see it is the length of the vector is updating here in panel and as well as in Rhino. So vectors are used very much in algorithms. So there are many options. You can see unit x, unit y, unit z. We have used already them. We have used this one a lot of times to form the vectors from three coordinates. This one sets the amplitude, and you can measure the angle between two vectors using the angle component. Cross product is actually very useful component. What you can do if you have the two vectors and you need a vector which is perpendicular to both, you can apply cross product, which will give um, the the perpendicular vector dot product is can be done from here, and the reverse we have already used. If you have a vector and you want to rotate it, you can use this component. So there are many things which can be done with vectors have the flexibility to not just only control the magnitude and also the direction, which makes it even more useful.